There we go. Hello, everyone.
And we are live.
We're very live.
And on time this
I
time?
hope.
Yeah.
Right on the mark.
Yes. Hi, guys.
Hey, Patrick. Can you hear us? Can you hear us all right? Because we changed places, so... Echo? What? Do you mean like... No, that's fine. Do you mean like echo from the room, or is the audio kind of playing twice? Audio twice? No!
Check.
Yeah, this one shouldn't really affect it. Are you sure it's playing twice? You good. Because I have someone here saying that it's not playing twice. What about you guys? Is the audio fine? Oh, it's you, Patrick. Come on, man, fix your computer.
Okay, so if you guys have any questions now, go ahead.
Oh, that's good. That's good to know. Because, you know, there's a lot here you don't see, so every time we're about to stream, everything fails. So we've been adjusting stuff. Yeah, pretty typical. Yeah. So yeah, guys, it's good to be back. Paulo is back. Yay! Yay. So we can finally do the second part, continuing our
sorry for the
stream.
delay, but I had to take 2 weeks off, so...
For good reasons?
Yeah, for good reasons. Good reasons.
So yeah, and what are you going to show us today?
So I'm continuing the last work that we discussed about the custom lighting, but this time I'm going to basically create a toon shader with an outline effect, both in the legacy system and the lightweight system, which is something that people have been asking us to do a bunch of times, and we never had the outline working for the lightweight system until today. Yeah. Cool.
Is there anything you guys want to discuss before we begin? At any time, you can always ask unrelated questions.
Yeah.
It's totally fine by us. And I hope the lag is also a bit better today. We changed a couple of things. Like last time, I think we had like 30 seconds of lag. Now it's around 4, 5, 6 maybe. Is it working?
Yeah, it should be fine.
Yeah, it should be fine. So do you want to walk us through a little bit of the demo setup you have here?
Yeah, let me just change here first.
Oh yeah, let's go into your camera, your view. There we go.
So let me just adjust my chair a little bit. So today I'm going to show you the toon shader, right? But before, let me just tell you that in this scene I have here, I purposely put a wall around the head just to create this shadow, because this is going to be a big issue for our custom lighting, both the shadow and the light. So I have a point light here, like a red point light, and I have these walls around just to create these cast shadows here on the head. And let's start by creating a new shader. It can be the surface one. So
we're going to start with the built-in renderer first.
Yes, I forgot to say that.
Oh, sorry.
I'm using the built-in renderer for now.
I'll not narrate as you.
Yeah. Let me just drag around some windows.
Hey, Cameron.
Hopefully you can see.
Oh, sorry.
Yeah.
I was just saying, Cameron, hey, we didn't plan to go over specific multi-pass templates. I think that's what you're asking probably. I'm not sure. But if there's any specific question you have about them, Paulo would be happy to elaborate.
I do remember that on the last stream, someone asked me to show you how you create, like how you code a new pass into a template. I can show you how I did on this one, because for the outline to work, and I'll discuss this later, I had to add a new pass, so I can show you the code in the stream if you want to.
Awesome. So stick around and we'll get to that. But you can always check us later if you can't follow the stream.
Yeah. So I'm creating a material for this shader now, and I'm going to just drag and drop on top of our head here, just to make sure that you guys at least know what we are trying to get to. I do have one that it's already set up, just so I can.
Nice.
This is the final result that we are trying to get to. It has the typical cell shaded style. It has a rim light, and it has an outline it's a bit special, this outline, because as even if you zoom out and zoom in, the outline width stays the same, and only after a few meters away that it's getting actually smaller. So
it maintains the line width. That's cool.
So this is what we're trying to get to, and now let's start on the empty one. Okay, so the first thing that we need to do is to change the main surface type, shader type to, the main light model to the custom lighting, and we'll be using mainly the custom lighting port to do all the rendering. And as you might at least remember, or at least try to remember from the last stream, the main component was the dot product between the normals and the light tier, or the light direction. So in this case, I'm going to repeat that process, and it should be the world normal and the light direction. Both in world space, create a dot product node, and you should have this result. So why we are doing this? Well, basically, we need to have something like a change of rate of the angle of the surface in order to create the cell shading style. So we need to map this black and white result that we have here into something that we can work with the cell shading style. And to do this, we first need to remap these values, because otherwise about half of the whole head is totally black, and we need to get the range from going to white to full black on the other side, but not like all this black. So we need to scale this down by using the scale and offset nodes, and just do, you can even preview it here, so like this. And now it goes from black to white. It looks a little bit too whitey because I have the point light here. Let me just toggle it off for now. So yeah.
Much better.
Now we drive this by using, it could be a texture, but in order to make this a little bit more interesting, we're going to use the gradient node. So we'll be adding the gradient sample node and a gradient node. So what this does is that we can actually generate a gradient. For example, I have a preset here, and we can drive the gradient with the result from the dot product. And if we output this, you can see that we have like a rainbow effect.
Far out, man.
So instead of this, we simply use something like some cell shaded colors, some blocks of colors. In this case, I have this one prepared. We'll be using this one, but we can change this later. And as you can see, it has like a well-defined edge between this cell and this cell. I did add a little bit of gradient on both sides. So
I see your question, Patrick. You have a big question. You want to make a mask based on the normal facing point in world space.
Make a mask based on the normal facing. Can you maybe...
So you want to highlight?
A mask based on the normal facing point.
What are you trying to do?
I'm not actually understanding the question, sorry. Omni projection. I'm totally lost here. Just try to rephrase it. I'll continue this part. I'll try to get to your question later. The previews.
So yeah, we were using a gradient to generate the
Yeah.
cell shaded effect.
This will create the typical effect for the cell shaded. I'm going to add a little bit more detail by, for example, using a texture to tint this, because right now this is only reacting to the light. So if I change the light around, you'll see that it's reacting to the light, but it doesn't have any texture on it. So I'm going to add the texture. I'll be using the one that I'm always using for this head. So, and I'm going to multiply the results on top of it. And I forgot to change into the material modes, and that's why. Come on. Okay.
There we go.
Okay, so it has the texture and has the cell shaded style on top of it. This is the most basic kind of cell shaded style. There's many other kinds. For example, you could use like the vertex colors to create the cell shaded colors, or the cells. I mean, this is the most basic one, and we'll be adding a rim light and the outline on this. This is almost the same as the sample we already provide, but we are going to do some special stuff here. So now that we have this part, one thing that we clearly see that it's missing, it's actually not receiving any shadows. So it does react to the light, but it doesn't actually react to the shadows being cast on top of it. And we need to use the light attenuation node for that. So if I show you the result of the light attenuation, it contains the shadows that you want to work with to make this work. However, if I now just, I don't know, maybe multiply the results, it gets a little bit weird. So it's kind of like realistic shadows on top of the cell shaded style, so it looks awful. So instead of this, we actually want to multiply the results of the previously created dot product. So in this case, I have this, and I want to change these results to something like this. This way, when we drive the gradient sample with these results, the darkest parts will get the darkest parts of the gradient.
Much more balanced, yes.
Yes. So now it reacts to the shadows being cast on top of it. Okay. So now that we have this, another issue that can arise is that if you want to use a point light, if you remember from the last stream, I talked about the issue that the point lights in the legacy system work with the add pass, which is another pass that is being added on top of it. And if we do nothing about it, we kind of start getting weird results with it. So if I now activate my point light, let me see if I can. I don't know if you can see it like a square being shown here. Maybe the stream can't tell, but there's like a line dividing.
Yeah. I think they can see, especially on the ear. Yeah, there's like a vertical line.
Yeah. And if you remember, the solution to this was to actually use the light color, which contains the fall off for the point light. So we actually need to add the light color as well. And we need to multiply the light color by the light attenuation. However, now that we do this, what we have here is that we actually have like a float tree or vector tree component being multiplied by a float one, and it's being cast in the time port for the gradient sample as a float one. So this vector 3 is being converted back to a float 1, which doesn't actually make sense. So what we need to do is that we actually want to kind of calculate, like loosely calculate the desaturation value of this calculation. Because if I show you the results from this on the custom light ports, we can see that we have like the smooth grading going on. So it's correct, but we need to actually get a black and white sample from this. And we can do this simply by using 2 max nodes just to get like this is not actually accurate, but it's a crude approximation of the thing that we want. So let's use the breakthrough component and 2 max nodes. And we are going to measure which value is higher. And by doing this, we actually get a black and white result from that calculation. And this is going to be the thing that we're going to multiply over the dot result product. And I forgot to connect here. So yeah, now it's reacting. However, we lost another feature, which is we lost the color of the point lights. So it's reacting correctly, but it's not actually tinting it like in the red color or something like that. And we can simply do this by just multiplying the result from the albedo with the light color. So in this case, I can just, let me just get some room here. Multiply this one, and now we get something.
Very nice.
But again, we now have a new issue, which is because this light color is multiplied by the light attenuation, we now are also multiplying the albedo with the shadow again, so it's getting really dark. So we now need to do some special work. It's not really hard, but at least it's a new way to add a new node or make you understand how these nodes work, which is we need to filter out what is being calculated in the add pass in the forward pass. So we only want the result from the add pass, which is the one that contains the point light attenuation, but not the one with the sun attenuation. So these shadows here, these hard shadows here. So we'll use the static switch.
Just real quick, Herb is asking if we have a node to convert to black and white. I'm not sure.
Yes, we do. And actually, we could use those. I can show you the difference between those. So let me just connect here so you can see the result. And that's why we are using the max one. So this is a result that I was previously calculating. I can actually use the one that's actually called grayscale, so actually really straightforward. And this one actually has 3 types of grayscale values. They are all calculated differently, and they all give different results. I simply found out that just by trial and error that the max result is the one I was looking for. Yeah. So it's just more like a...
Not a strict rule then.
Yeah, it's like I said, this is only a crude approximation. You could use the grayscale node and try different styles, I guess. I wasn't really happy with any of those, so that's why I ended up using this 2 max nodes here. But yes, that's a good question, and I actually had tried this before. So like I was saying, I wanted to filter out the results from the hard shadows in this multiplication here. So I'm going to use the static switch on the fetch mode, and I'm going to select the forward base keyword. I don't need the material toggle here, and I'm going to let me just check. I'm going to say that when it's forward base, it's the point lights. So I'm going to multiply it here, and when it's the forward base, I'm going to say that it's a value of 1. So When it's the forward base, it means that it's the light attenuation from the sun, and I'm going to multiply it by 1, so it stays the same, I guess. And when it's the forward add pass, which is the point light attenuation, we are going to multiply the results with the albedo, and then we get the colors from the light color. Yeah. Okay, so this is mostly done. There's just a few other things. First of all, I actually like to use the light that comes from the point light. So I like to use the indirect diffuse light node, just to make sure it gets a little bit more grounded to the scene. So if you have like a mix between tune shading and real shading, real size shading, I guess, this node would actually help you. And a really nice way that we can use this is by actually add the results from the point lights, which I can show you the results here. We can use this in a way that it actually makes sense to the final result. So I'm going to multiply. Let me just show the result, the albedo, to this value here. So it kind of looks like it's in shadow, totally in shadow. And I'm going to add this value to the I think it's this one. Maybe I did a mistake. No, I'm going to add this value here, something like this. And now it looks a little bit better, and it has a new feature, I guess, which is it now reacts correctly when it's like a day or night. Not this one, but if you have like point lights here, yeah, it gets darker. So I have the generation on. So
cool. You guys are very quiet today.
So yeah, this is one of the little details, and now we'll move on to the outline effects. And for the outline, in Legacy, it's actually really straightforward because we actually add like a simple option that you can use, like the outline checkbox.
Oh yeah, the old option, yeah.
So if you use this one, it's it's basically done, I guess. We can just change the outline width. Like a small value or something like that. However, this has some of at least some issues. You can see that the nose is really strange, the eyes as well. Even if I put something a little bit smaller. So you want to customize this outline, and we'll do this by using the outline node.
Yeah, we're going to do this effect in lightweight after we're done with the basic build-up.
This is going to be our base for creating the lightweight version. So I'm only starting here just so you can make sure that you understand this part. And when I move over to the lightweight, I'll talk about the differences, and the most important part will be the outline part, which is the one that is really different from the lightweight version.
Yeah, but feel free to shoot us any questions you might have. It's no problem.
Yeah. So this node is a way to customize the outline look. We just connect this to the local vertex offset, and now we can change the way the outline works by choosing some different options. For example, we could just change the offset of the outline by hand, for example. And this is what we are going to do now. We are going to do our own custom outline, and we'll see in a moment why. But for now, let's say that I wanted to create our outline. I can simply use the vertex normal. And I'm going to something like this, like I'm going to use the vertex normal multiplied by a value, which we call it, come on, outline width.
Hey, Vesa? Sorry if I'm mispronouncing that. We have around 10 people. It varies. It's not a rude question. That's all right. We're a rather small team, so we're kind of divided, so to speak, into different areas. We have some people working on specific products or even games. We recently shipped a game called Decay of Logos for multi-platforms. But the actual tech team working on this product is between 2 to 3 people. So it tends to vary a bit.
Yes.
I hope that answers your question, but let me know if you have any others.
Okay, so how, like I was saying, I'm customizing my outline, and I multiplied the vertex normal with a float value, a property value, and I'll connect it to the offset. The reason being that to do the outline, we only want to extrude all vertices in the offset in their normal way. So by changing, for example, if I introduce like a negative value, you can see the result getting really weird. Now it's inverting the outline.
Oh. You
can see something in the ear here.
Oh, sorry, great, Orion. Maybe I didn't speak loud enough. I said Decay of Logos. It's another game. Oh yes, very, very efficient. We work very hard on these products, but thankfully, since we, have been developing them for a while now, we kind of got used to the development cycle, so to speak.
Okay, so this is the same result as not having the outline node, right? So now the reason I'm doing this is because now I want to customize this a little bit further. You can see that the nose is really weird because the distance to the outline, because it stays the same alongside the edges of the model. On the nose, this distance is a little bit too high. It would be nice if you could customize this distance, this width of the outline, so it could stay smaller on the nose, for example, and in the same case for the eye. So the idea here is that I actually already prepared this model in a way that on their vertex colors there's some information that we can use to make the width higher or smaller depending on what we want to do. Cool. We can do this with the vertex color, but there is also the information on the albedo map. So if I show you the alpha for the albedo map, you can see that. Let me show you. You can see there is some gray areas. Some gray here, some white on the other stuff. And if I use this alpha channel and multiply this by the result that we already had for the outline, we can see that the outline will get smaller only on the areas that are gray.
Cool.
So as you can see, now it's smaller on the nose and bigger on everything else. Same for the eyes, smaller on the eyes, bigger for everything else. So this is one of the reasons. The other reason is I showed you earlier that we could zoom out and have like the constant width for the outline. It's not the case here. So if I zoom out, the width of the outline gets smaller, and eventually you don't even notice that it has an outline. So what we want to do is kind of do a simple trick, which is we can get the depth information, or not the depth but the distance to the camera on the vertices, and we can use that distance to make it constant on the amount of width that we are going to use to the outline effect. So we are going to multiply or add another value to this multiplication here that comes from the clip position. Sorry, clip. So object to clip pos, and we are going to add the vertex position node, and we want the W value. So if we multiply this directly, we now get a constant value for the width. So even if I zoom in or zoom out, however, you can see that now we have a different problem, which is if we zoom out too much, we actually get really thick lines, which is not what we are looking for. So we need to just max this value into a certain value that we can customize. So you can just, not the multiply one, but max one.
So Unique Playstyle asks, what if we want to make the highlight, I think you're referring to crosshatch effect, like half-tone circles, that kind of effect you usually see in cel-shaded stuff. It's a bit of a different effect, I think.
He may be asking about the highlight, like using the outline to do a highlight, maybe.
Is that what you're referring to? I'm not familiar with Spider-Verse. Do you mean the movie?
Okay, so that's it. I guess you could change the color. I didn't change it yet, but I'll change it in a bit. If we add like a really strong color, white. Why didn't it change?
Yeah, Cameron, we do know the movie. It's pretty awesome. If it's the animated one, is it? Spider-Verse, it's the animated one, right?
It's the animated one. For some reason,
pretty good.
It's
Don't remember that particular effect. There was a lot of stuff going on in Spider-Verse. All of it awesome.
I think about like 20 should be enough. Is it max? Sorry, it's not the max one. It's the minimum value. So we want the value to stay at the minimum value
Hey there,
and not
Riley.
get any higher. Yeah. So something like this. And now if you do, okay, something like this. This could work for a highlight, I guess. It doesn't highlight only on the edges. We can fake it a little bit by making sure that we render the outline a little bit further from the object. This introduces some other problems, but we can talk about this on the lightweight pipeline, because there's actually a really cool trick that we can customize the outline even further that I'm going to show on the lightweight pipeline. So this is the final result. I can change the color. Okay. And we get like a simple colored outline on the cel-shaded style, on the cel-shaded surface. I actually don't use, or at least I think a more practical way to do outlines is to actually use the albedo color to tint the outline. So instead of just using a color, I actually prefer to grab the results from the normal pass and just stick it into the color and, for example, multiply it.
Sounds like a good idea, yeah.
And now we can tint.
Quite tinting. Is it?
Yeah.
Oh.
You can see that it's being tinted.
Sorry, I have a light on my eyes.
So something like this.
Herb asks, how expensive would you judge this shader to be compared to a default lit shader?
I would say this is faster. I don't think it's much different. There's still at least one missing part here that would change my response, which is it doesn't have any specular component.
Mm-hmm.
So in terms of performance, this is probably still a little bit faster because it doesn't have any calculations for the specular component. However, we do want sometimes to create a specular component, but not in the traditional way for toon shading. What we actually want to do is create a rim light effect. And I actually have it prepared for this stream.
But in terms of performance, they'll probably go hand in hand.
Yeah, I guess so. At least when we have the rim color effect.
We got a couple of other comments. Let's see. Yeah, hello, Silversaw. They might have been talking about the typical dots usually associated with comics. It's a bit of a different effect to make. I'm not sure if you're prepared to kind of show that.
I think I can show it. The idea here is that we can paint both the cell shaded style and the outline with a pattern.
Yes.
So we can use the screen position.
So this is specifically for the outline, Silversaw, but there are, of course, other effects where you can actually combine other things like crosshatch and things like that.
Yes.
It's a bit more evolved than what we're showing, but Paulo here will demonstrate.
So I can use the screen position.
I see what you mean, Silver.
And just connect it to a different texture. The only thing here is that I actually don't have any good texture to show the pattern, so I'll use these checkers, I guess. I could even just paint, for example, let's say something like this. I could multiply it here. I'm not sure if it's going to look really good or not, but
I think we have like a fence, metal fence, chain fence, maybe.
It's working,
it's doing something.
But yeah, it's doing something, but not really. Yeah, not this one. Sorry. So something like this. Okay, this is doing something to the cell shaded style, not only for the shadows. We can filter this by doing a LWRP between 1 and 1 and use, for example, this. Okay, the other way around, so like this. Not going really okay, but the idea, it's a start. The idea was to create. Let me just try this one, just a last try. It's okay-ish, I guess. So basically, the shadow parts have the screen effect that has the pattern, and the light parts don't actually have it. And we can do this for both the cell shaded part and the outline. So we could have like a scratch effect to make it like a crosshatch effect, you know. So yeah, I guess this could work, not with this texture because this is a really bad texture. I'm using this one, so not a good one, but if I have a different one, maybe more about the style you want to do.
All right. You want to take us back, maybe kind of recap?
Yeah, so the thing we are missing is the rim effect. Rim, but maybe we could move out to the lightweight, and then we can do the rim effect there.
Yeah, let's go for it.
So now that we have this here, I want you to notice one important part, which is do look at the point lights and notice that it's adding the red color on top of the object, okay? And I want you to memorize this image in your head, because in the lightweight pipeline we can actually control it a little bit further and it will look differently on the lightweight pipeline. So let me just save this in. And I'm now going to change it to the lightweight. Okay, so this is going to be the final result for the lightweight pipeline, and notice right away that the red component
looks a bit different, yeah.
It's not actually being just added. You can tell that it's actually consuming parts of the cell shading stuff, you know. So this would be the result for the shadows would be being cast here. So the point light is actually consuming, not only it's adding the red colors, but it's also consuming the cell shaded part, you know.
Cool. Very nice effect. Patrick is asking if we can use noise on the outline. Can actually, I think you're referring to the actual noise node, probably.
A noise, like making some parts more with a higher width and other parts with a smaller one. Is that the kind of noise you are referring to?
Perhaps an animated, sort of animated outline, like
the only
shaking.
problem with this kind of noise is that because it's being used, it's being
Yes.
created by the shape or the mesh of the object. If you have like a really small object, like a low poly object, you may not have like enough geometry to make the vertices go up and down in a really good manner. But yeah, we could just, for example, add a time node or even one of these, I guess, and multiply it. Not on this one, but on the legacy. But I'm doing on the one. I'll show you. Do remind me of that. I'll see you in the lightweight pipeline, so you can move out to the lightweight pipeline. So this is going to be the final result. I have the rim light here. On the other one, I didn't. So let's start from scratch. I'm just going to duplicate this and create a new shader. Actually, I'm going to duplicate this shader. Yeah, I'm going to duplicate this shader, and so we can preserve all the nodes, all the tree that we already have, and we'll start from there. Okay, so these names.
Almost there.
Yeah, sorry. And it's still pink because the shader is still the same as the other one for the legacy system. Let me just delete this part here. Okay. So now this is the old shader. I'm now going to switch to the lightweight pipeline and going to the unlit version. And let's just ignore the outline node for now, and let's just connect the output from the cell shaded parts and see what we get. Okay, so it's mostly working. There's some caveats here, which is, as you can see, there's no point light. The red point light, it's here, but it's not actually affecting the model. And the reason being that, as you can remember from the last stream, there's some things that we need to do to make the point light work in custom lighting. One of those was to actually recreate this part here with the custom expression, or with the special node that we added on a few weeks ago, which is the additional light node.
Yep. So, Patrick, it's an interesting idea. Do you mean kind of generate shaders for other SRPs automatically and all that?
Populate PBR, so something like an automatic switching and not sure what you mean by that, but
I see. Well, I guess we could automate that process, but I think in this case we prefer to give the user that control, like what specific type they want to use per shader.
I think if you change it from a standard surface shader from a PBR one, if the connections have the same name,
on the same shader, they change automatically.
Yeah.
What's the SRP?
Okay, so what's this shader function? I can show you, but it's a little bit complex, but it has a few custom expressions here. What they do is that they actually return the values for the light attenuation for point lights. The way the lightweight pipeline works is that we need to treat the point lights in a loop inside the shader. Before, in the legacy system, we could just simply use the add pass, and the add pass would simply add the results from the point lights on top of our rendered model. In the case of the lightweight system, we need to actually loop around all the point lights in our scene and add the result from their contribution to the rendering of the actual model, and not a different path. So what this node does, it's actually, if I show you even the code, all of them have like a for loop that goes around on all point lights, and they do something different. So what this node does is actually you can choose what kind of types of light you want to do. So a flat lighting, a Lambert lighting, or a specular lighting for the point lights. And all the other nodes that before would give us either the color or the attenuation for both lights, meaning the sunlight and the point lights, they now only give us the results for the sunlight, so the directional light. A flat light, I'll show you. I can actually show you the result.
Yeah, and if you want to see this in action, our last stream actually covered this. So if you didn't have a chance to see that, I recommend you go check it out. You can probably find it in our site, in our YouTube channel. There's a playlist there.
So this is the flat light, so it's only giving out the fall off of the point light. If I show you the Lambert one, you'll see what I mean. Now it's actually trying to calculate the contribution to the surface. And this is the specular one. Okay, so now we are going to use the flat. Sorry, I'm going to add on top of the result that we already have, which is this one. I'm going to add the result for the additional lights as well. And I'm going to do this in a similar way that we did for the regular light. So I'm going to duplicate these nodes here, which are the nodes that we could substitute by the grayscale node. And I'm going to grayscale the additional lights.
I don't know if you can do that, Patrick, using that node to create a subsurface scattering effect. I mean, you could try to fake it.
Yeah, you could. It's actually similar. I think the SSS effect is basically the Lambert light with the normals inverted.
Oh.
So basically, yes, you could, not in this way, not with this node, but you can hack the code to make it work for SSS. Yes. It's not actually SSS, it's actually called translucency, but yeah, it's similar. Okay, so let me just consult with the one that I already have prepared. So now we are going to add this result.
Oh, wait. Sorry, I just kicked the mic. You're welcome.
We are going to add this result to the result from the lights from the sun. So this is the light from the sun. It has the shadow and has the attenuation correctly. And now we are going to add the result from the point lights. And we do this before going to the gradient sample to make sure that our gradient sample now picks up the contribution for both the sun and the point lights. So this is the main reason why now the point lights don't actually add on top like a red color on top of the other result, and they actually contribute to the sampling of the gradients that we use to create the cell shaded style. Finally, we still need to color it like we did for the light attenuation, and now we actually don't need this anymore. Before we had to do this because we actually had to deal between the add pass and the forward base pass. We can actually just delete this. By the way, I used the Alt and drag to remove the node.
You should know this by now, but if you don't, there's like a button there you can press, and you see all the shortcuts in the editor.
I can show you more specifically. So I'm not actually. Let me show you my hand. My left hand is not actually doing nothing right now. But if I now press Alt while dragging and leave it on top of another line, it will auto connect between those two.
Just like magic.
And if I hold Alt and drag, it will also remove it. So it's a neat little way for adding.
We also have a small little window for information about our shortcuts. You know, the Y
Yes.
button. So there's a lot of magic hidden in there. If you're not familiar with our shortcuts, there's a lot of stuff there that will save you time. So
Yes.
be sure
You
to
can
check
check
out.
this out, and the colors, and you know. Okay. I got sidetracked. Where I was going? Okay, so I need to add the components. So it's, yeah, I was missing tinting, the light,
Get the color.
right? So now I also need to multiply the results for the lights, the additional lights here, and by the albedo, just like we did for the regular lights or the directional lights, and we need to add these results, either add or multiply it. Yeah, we need to add this. Well, this actually, you can do this differently. I'm doing this this way, but you could do it in a different way. I'm just going to add this directly on this final add here.
Just real quick, Andrew asks how to swap a wire connection without leaving one disconnected. Well, you can drag wires, but you can also alt drag, and if there's two, I think the second one remains connected, right? I don't quite remember actually.
Swap wire connection without leaving one disconnected. So let's say that we have something like this, and you want to switch these two, maybe. How to swap the wire connections between? Is it
Maybe
Andrew?
in between when we have more than one? I'm not sure. Can you elaborate, Andrew? We'll try to answer it.
Because if you instead of holding, if I drag this connection and hold control and leave it on top of the other one, they actually switch. Is that it?
I didn't know we could do that.
Okay. This also works in the same node, so something like this.
That seems handy.
I'm holding control here to do this. Okay.
Awesome.
So I added the result from the additional lights multiplied by the albedo to the final result, and yeah, that's it. Sorry, I'm a little bit lost
Yeah,
here.
Paulo keeps adding cheat codes to the editor.
Yes. And there's more coming, by the way. Okay, so for some reason this is not looking. I did some mistake here somewhere. I think it's this one. So this is multiplied by. For some reason it's not looking like the other one. Let me just check the result for the sample here. This looks correct. This also looks correct, maybe? Yes, this one looks correct as well. So probably this one.
Bear with us, folks. We got a little sidetracked with all the questions.
I'm
Just have
doing
to-
something wrong here. Let me just find out what it is. For some reason, it's really bright.
Hmm.
I guess we'll go with this. For some reason, this is not doing the cell shaded thing here with the point light. Not sure why. I'll think about it while doing the rest. So now we need to do the outline.
Yeah, feel free to ask any questions, Ozgi.
Okay.
It's no problem.
Okay, so before we actually had that option for the outline, and we could also use the outline node. This outline no longer works for the legacy system, or for the lightweight system, because this actually was like a hack to the surface system, to the first surface shader. So this no longer does the hack to the lightweight system. And in order to do the outline, we actually need to create like an extra pass that actually renders just the outline. And there's actually various ways to do this. And we recently added, and by recently I mean today, we added a new version.
And this is live now?
Yes, I don't think it's on the asset store yet.
Oh yeah, on our site.
But it's on our site. And it has a new option that you can find here, which is the extra pre-pass. And when you click on it, we'll actually add a new master node with that only renders the extra pre-pass. And this will replace the outline, so I no longer need the outline node. And I can use this to make the outline. But there are some caveats by using this system. What we need to understand is that this pass is being rendered before the other ones. So in this case, it's being rendered before the final result for the head. But we need to change it a little bit in order to make it work like we want to. Before on the outline node, it was already set up for us. And one of those things is we need to actually tint it and make it invert the surface in order to make it like the outline. Because if you didn't notice yet, the outline is basically re-rendering the mesh again with the back faces switched. So basically, if you want to render the outline here, we need to change the back faces from back to front. So this is basically the only thing we need to do. And by doing this, we now can just connect the same ones that we had before. And it's not working because of this distance here. Okay. So yeah, it's using the same system. Sorry.
Was that clear for you guys?
I can explain it again. So basically, the outline node that we had before was exclusive for the surface system, and now we need to do it in a different way. So we need to add a new pass that does the outline, and we added this on our template system. You only need to activate the extra pre-pass button here. It will create a new master node, and this master node it runs before the other one. So we need to just color in the same way that we had before. You can color it, you can change the vertex offset, and you can also change the alpha if you want to. But the good thing about this system is that we now have a lot more options for this pre-pass. So you don't actually need to use this just for outline. We could do other stuff with this pre-pass. There's some effects that it doesn't. For example, I'm not sure if I can say this for sure, but there's at least a few effects that we want to do with depth that needs like an extra pre-pass that only renders the depth buffer. We could try to do that, but yeah, this is a simple way of creating the outline. Okay, so this is the outline in working for the lightweight system. There's at least two missing parts, which is the rim lighting. This is more performance. Yes, this is only working for the lightweight and the universal system, so no HD for now. And the reasons being that the HD system is a little bit different, so some nodes can't work, or at least they can't yet work for the HD system. I actually mentioned that in the previous stream. So if you want to know more about the HD version, go check it out, and you'll know why it's not working the same way for the HD system. But at least for the lightweight and the universal is working.
Cool. Like I said before, you can find the other streams on our YouTube channel. We actually have a lot of playlists there. If you have not checked them yet, you can find the streams, you can find tutorials, beginner series, or just go to our wiki at wiki.amplify.pt, and you can find a lot of stuff there very easily. I didn't quite get your comment, Alex. You know what's coming? Stencils? You want stencils? Is that it?
Cameron asks if the past template work for HD? It could. I didn't add it yet, but I can add it for the HD version as well. So just to finish this, there's two things that I want to mention. I want to create the rim light, and I want to mention, at least I want you to pay attention to something that you might not yet noticed, which is if I increase the distance or the width of the outline, I want you to notice something. Check the shadow here. If you can tell, it's actually, this is the shadow for the floor, and the shadow on the floor is actually being rendered on top of the outline. And this is actually true for basically every shadow. So you can see the shadow here on the floor is also being added on top of the outline. This is actually a mistake that we can fix it with just this. And I want you to show you a way to make the outline work for any case, even with the correct shadows. But I'll show you at the end of the stream. It's a little bit more, it's not more complex, but it's a trick on the rendering system. And I want you to show it that later. But for now, just pay attention that you can actually have like this working totally correct. But for the most part, it should be looking fine. Mostly people just want to tint it in the flat color anyway. But okay, so let's move on to the rim light. We'll do the rim light in a very simple way. We'll use the idea of a Fresnel effect, and we'll just cut the parts of the Fresnel effect that are not contribute. Sorry, we'll cut the parts that are on the shadow parts. So it will only see the rim light effect on the actually on the parts that are actually lit by the sun or the lights. So we do this by using the view node and the normal, and we do a dot product. And if I show you the result of this dot product, this is actually kind of the same as the dot product between the world normal and the light direction. So you see that the faces parallel to the camera are always white, and the other ones get darker and darker until they go black. Let me just for now remove the outline. And now we want to control this in order to create the rim light effect. So we want to eventually invert the result. And we want to change these values around in a way that we only get like a rim of this effect. And I'm going to do this by adding a value that I'm going to call it rim offset. So we can customize it. Okay. Something like this. And if you remember, I actually used the scale and offset on the dot product between the world normal and the light direction, so that the values that are negative get like scaled down to 0. In this case, I'm just going to saturate the values. Saturate means that they are getting clamped between 0 and 1. So this is basically the same as using the clamp node, just like a shorthand of using this one. And I'm going to let me just save the result for now. And I'm going to use the smooth step value just to make it so they don't get this hard, like a hard fall off.
Transitions, yeah.
So it gets a little bit smoother. And I'm going to tint this with the color, so I'm going to multiply it by a color, which is the rim color. Something like this. Okay. And finally, I'm going to cut out the parts that are dark from the shadows. So, which means I'm going to just reuse the values from the light attenuation. So, what is it? So this one, I'm going to multiply it something like this. Yeah, something like this.
Cool, very cool.
So now we need to add this to the final result. So the final result was this one.
Means you're getting a hang of it, or
And just add this. Okay, so it has a small rim effect. Let me just adjust.
it's much more interesting than just using the Fresnel effect on top of it. Yeah.
Yeah.
Really.
And we can adjust the smooth step. You can even expose it to the material properties. For example, I'm not sure if these values will be looking good, but
Oh, you got rid of it.
sorry, wrong one. Yeah, it could even go really strangely looking, something like this, and then adjust the offsets so it's more toony looking, I guess. So yeah, this is the rim effect. I guess the only thing missing here is the explanation of the outline with the shadow thing that I showed you earlier, which is basically the reason this works is because we are only rendering one pass before the other ones. However, if you want to actually be able to receive and cast shadows for the outline, we actually need more passes. We need the pass for the shadow caster, the pass for the depth buffer, and these passes, while we can add them, if we add them to the same shader, what will end up happening is that Unity only picks one of those, and our shader already has those, because our shader already is casting shadows. So if you want to, if you add two shadow casters, for example, one for the outline and another for the object, only one of those will be picked up by the rendering system. So we can't actually use these extra shadows or these extra shadow casters or these extra depth passes. We need to fake it in a different way. And that way is actually, it's kind of stupid, but it works. And
Well, as long as it works.
It's a way that you can fake it, I guess. So I'm going to duplicate my head. I'm going to move the other one to here, I guess. And I'm going to...
Are you about to do what I think you're about to do?
No, but we'll see. I'm going to duplicate this shader. And I'm going to call it outline. That's because it will only contain the outline.
Yeah.
Okay, so I'm going to create a material for it. And I'm going to do something kind of crazy, but it works. Which is, I'm going to select my object here, and I'm going to increase the material size to 2. This will actually render the same thing twice, because it is using the same material, but I'll now use a different material. And I'm going to change this material, so I'm going to open up in the editor, and I'm going to now remove the extra prepass, we no longer need it. And I'm going to only render the outline on this. So basically it's like a new shader that only has the outline. And for because of the way the outline works, that we need to invert the culling of the faces, I'm going to change it to front. And I also need to connect this one for the vertex offsets. And now, let me see if I... something like this. And now if I increase, you can see that it's, let me try to see on the floor, even the outline is casting shadows now. That's because we are actually rendering the object twice, one for the outline and another for the actual rendering of the object. This is a little bit more expensive. We could, for example, try to not cast it, make it not cast shadows, and maybe save a little bit on the floor. But the reason we might want to do this, it's up to you if you want to do this or not, is because now the shadows that are being cast on top of the outline, if I increase it, they now change accordingly. So this is the result for, before we could see the shadows from the ground here, and now they look fine.
Yeah, I mean it's more expensive, but
it's up to you. It's
really works.
If it's something that you really need to do, go for it.
For sure.
So we basically fool the system by using two different shaders.
The old trick.
Yeah. This is the old trick, the old way of doing it. So I had like some answer to give on the end.
There was a multipass or
the multipass.
The
what was
template.
it?
Is it a scroll up? Yeah, guys. So we're kind of finishing up. We're gonna go through your questions, see if we missed anything. But if there's anything else you want to ask us before we go, now is the perfect time.
I had someone...
Yeah, there was a question about our template. Sorry guys, just 1 second. Looking for a question here. Wasn't it before?
Can't find it. Can't remember what the question was either. Showing you the code, was it?
Yeah, something about showing code. Showing the template code.
Okay, so Alex has a question. I have two. Please could you go over past the template creation? Okay, yeah.
Got it, Cameron. Thanks.
Okay.
We're looking for your message but couldn't find it.
Okay, so the way I created this extra pass is actually really simple. Only because it's something that I reuse from some other part. So let me just open up Visual Studio here. So we'll see a little bit of code. Hopefully you don't go away.
Oh no, we just lost the chat.
Let me just drag and drop.
It's back.
Okay. Let me just... Okay, so before today's update, we actually had 3 different passes in the unlit version of Lightweight Pipeline. So it was the Lightweight Forward, the Shadowcaster, and the Depth-only passes. And what I did was I actually just duplicated one of these and put it on top. And the way the system works is we actually have these small tags here. We can either add or change accordingly what we want to do. And this will be read by our system, which will parse the code and will try to figure out if we have the culling, if we have the blend modes, and so on. So we only need to add the this pass here for the creation of the pass, and we have other ones for where the global variables and the definitions go into. So we have this one for the pass. These two are actually essential, and the functions as well. So if you want to add like a function from the custom expressions, for example, they go here. And then these parts are for configuring what the shader already contains inside of these structures, which will be used by the shader for the input of the mesh and the interpolators. So in this case, our mesh has the position for the vertices and the normals. So we only do like these small descriptions that the position is being used and the normal is being used. And the same for the interpolator. So in this case, we have a position, we have a value that we say that it's the world position that is saved on the textual coordinate 0, and then we have other values for the textual coordinate 1 and 2, and we do something similar, that we say that the world position is saved on the textual coordinate 0 and the shadow caster on the textual coordinate 1 and so on. Mm-hmm. So we do this, and we then create the tags for where the output ports go. And this will be defined in the final shader as ports. So by creating this one, for example, it will create the vertex offset port.
Cool.
And
see you later, Patrick.
And we do this for other ports that we might have. And eventually they show up in the editor that we can customize it and
this is detailed in our wiki page, Cameron.
Yeah.
Have you had a chance to check that?
Yeah, this is just a surface level view of the whole system. All these keywords that we are using for the tags, you can check it out on our wiki. Yeah. We have a full explanation.
And if there's anything on the actual wiki that you find that doesn't really explain what you're looking for, you can reach out to us and we'll try to adjust it or update it.
So I just added this pass and created a new option that works, that actually hides or shows the pass, and that's it. It's actually really simple.
You make it sound simple.
Yeah. I may not be the best person to judge.
No, that's all right. That was a great explanation. I think we got some other questions here.
So Alex writes. So Alex, I have two float 3, two float 1s. All of them use LWRP by the same texture alpha value. Would it be better to combine them into first and then LWRP? So you don't LWRP matrix values. Maybe I'm understanding the question, not understanding the question, but you can't LWRP. For example, you can't do this. This is not something that you can actually do. I'm not sure if the code will actually produce any compilation errors. I could try. But you don't need to do this. If you want to combine it into float 4s, and for example, if you have like a float 3 value and a float 1, and you want to do various LWRPs, for example, or if you want to do the same LWRP, you could actually combine this using the append node. So I click V for the append node. You can combine this and then do the LWRP. For example, like this. And this would save at least one LWRP instruction, because instead of doing the LWRP between the two float 3 values and the two float 1 values, you now have a LWRP between just two float 4 values, and you save one instruction, which is the LWRP. However, this actually has another side effect, which is we actually need to do at least one instruction extra just to append the values. So you might not end up saving instructions by doing this. Yeah, I actually do this when I have a major follow-ups of instructions that I want to do. Like, for example, imagine that I want to do 1-1 minus and the saturate. If I have a bunch of those, then doing this it's actually cheaper than doing something like this, which is more expensive. So in this case, I would have like 6 instructions, right? Which is these 6 nodes. And on the other one, I would have just 3 and probably 2 more. So in this case, I would be saving at least 1 or 2 instructions by doing this.
It's a good idea.
Which one?
Andrew asks, I want my sprite lens flare to disappear when something is in front of its center, like inside.
So the sprite lens disappear when something is in front of its center. If I'm not mistaken, the lens flare effect is done by the post-processing effect. So I'm not sure if you can mask out the lens flare. What I'm trying to say is that it's dependent on whether or not you can customize the lens flare effect. So if it has like a mask, you could probably create a shader that tries to...
Yeah, we saw the question, Andrew, no worries. We're going to go through all of them. We also asked how to sample depth at a center of an object and then fade it if something is in front.
How to sample depth at the center of an object? Not sure if I understand the question. How to sample depth? So you sample depth by using the depth fade node or the depth node. So screen depth, for example. Let me just create a new one, just to make it simple. Okay, so and let's.
Oh yeah, you can post a video, Andrew. Just make sure it doesn't have any music or stuff like that that could get our video flagged.
Sorry. Okay, so did a small mistake here. Okay. So you sample depth by using the screen depth node. However, you only get the result from the depth buffer if, in case of the lightweight system, if the object isn't a transparent one, because the depth buffer is only available after all the opaque objects are being rendered or are rendered. So even if I do this and I create a new material for it, you actually don't see anything. It's all white because my object needs to be a transparent one. And you can do this by, for example, changing, where is it? By changing the render queue to transparent. Maybe even the type for now, let's say. Let me just remove the glow because it's messing up my... Okay. There's one thing I forgot, which is we need to enable it in the lightweight rendering pipeline asset, so you need to activate the depth texture here. So with this...
Just real quick, Thomas, the actual name doesn't really matter because I believe it's associated with the actual shader file, so you can have shaders with the same name. So to speak.
But what name?
Regarding the shader name, I think you missed...
Two shaders with the same name in the common property?
I think it's referring to our name that we set in the editor, if I'm not mistaken.
Oh yeah, it's okay. As long as it's a separate file, it doesn't matter. It doesn't use the names for it.
Yeah, I think it's probably just going to show up duplicated in your shader list.
Yeah, it will. Okay, so this is the depth buffer. So you can see that it's actually rendering the depth from what it's behind it. And the question was how to sample depth at the center of the objects and then fade it into something, fade it if something is in the front. Yeah, it's kind of difficult to understand what he wants to do.
So basically you just want to occlude objects, is that it? You want to... Where's the video? We see your comment, but we don't see a video. Is it on the Discord channel? Oh, no, what is it? It's not fight.
Tá aqui o Discord.
Ah, ok. Não estou nesse caso. Hey there.
Hey guys, I was trying to make my character only render an outline when behind the other objects. Know how to start?
Well, there's the X-ray example, maybe.
Okay, so if you want to render the outline just when it's behind the other objects, you probably need to use the stencil buffer. I'll not say that it's the best way, it's just one of those that you can use, which is you need to render to the stencil buffer a value and then read from that value to make sure that only the things that are in the stencil buffer are rendered like you want to. So let's say that your wall, which is the thing that is on in front of the outline, is rendering to the depth buffer a certain value. You then, from the outline shader, read that value, and you only render something if there's already something in there in that stencil buffer value, which will make sure that they only render when it's behind the wall. I'm not sure if I explain it well enough. You can check out our stencil buffer examples.
It's alright. Just making some window adjustments here. So it's like you're looking at the camera.
Okay.
Yeah, so about the other one, I didn't really get a video, Andrew. Did you post it? Which channel did you put it on Discord? Oh, it's the inside one. You were in the right place. Just one moment.
Which one?
Was the general on the shader editor?
Here?
Yeah.
Ah, okay. Okay.
So do you have a specific time frame, time code for that? Oh.
So it's a quad that is being rendered.
And that's just the shader effect, or is he using a script for that? Because we can't hear the sound of the video, so it's going to be hard to understand what he's doing. We don't have any sound on this computer.
This is probably a little bit more complex for the stream. I can try to watch the video and give you an answer in Discord, I guess.
Or join us next time for...
Yeah, we could try to create something for the next stream, I guess. Yeah, it looks like a sprite on a sprite.
Yeah, we'll check it out, Andrew. No worries. It's just that we can't really hear anything here, so we'll have to look into it.
Yeah, I need time to think about it and give you a proper answer.
Cool. Also an awesome game.
Yeah. So it's the lens deflects sprites on canvas. And okay. So everything has a stencil value by default. No, you need to actually make the other objects render to the stencil buffer. So you need to make sure that the walls are rendering to the stencil buffer, and only then you can actually use another shader that does the outline and reads from that stencil buffer. You can check out the samples. I can show you here. Let me just switch to the legacy system, and I think I have, it's called portals, maybe?
Yeah, something like that.
Yeah, it's called stencil example. So you can see that on this example, there's actually a sphere, a cylinder, and the cube all on top of each other, and the corresponding color portal is actually rendering these objects. and that is done by making sure that only the so let's say that, for example, if I check out the shader for the stencil for the green one, it's actually using the reference 2, so it's outputting a value to the stencil buffer that writes a value of 2, and then on the object, which is the sphere, which I can't even see where the sphere is. Let me check. Object here. Okay. If I check on this one, I'm now comparing if my if the stencil value is 2. So I'm comparing if it's 2, and if it is, it renders. So it's keeping the value, but it's saying the same thing it's rendering if it's 2. So one is writing to the stencil value, to the stencil buffer, a value of 2, and the other one is reading, and it will only render if the value is 2. I'm not sure if it makes sense, Piglet Tank, but that's the way you do it.
Cool. Oh, Andrew has some more comments about the effect.
Oh, I guess they are trying to answer each other's answer, or maybe Cameron is trying to answer Andrew's answer. Okay.
No problem. Be sure to drop by our Discord if you have not already, and we can keep talking about the stencils. I actually have a question about stencils, just out of curiosity.
Yeah.
How do they work well in VR? Is that something, in stereo rendering, is that something we can
Good
take
question. I
advantage?
actually don't know.
Because I don't think I've ever seen it there, but it would be interesting. It would kind of create some
think
interesting
so.
effects.
I think so. I'm not sure if there's some limitation. I'm not sure, but I don't see why, at least. So they should work in VR.
Could be interesting. Do you guys have any other questions?
Andrew, if for some reason I don't answer you in the next days or so, do remind me, and I'll try to answer your question about the sprite on sprite stuff.
Sounds kinky.
So yeah, if we don't have any more questions.
Well,
I think we can.
let's take it to Discord.
Yeah. We can wrap it up and go home.
Cool. Hope you guys are ready for the weekend, as we are.
Be sure to subscribe to our channel and sorry.
Sorry.
And smash like.
Oh no. We're kind of joking around, but it really makes a difference because we see a lot of people viewing our videos on YouTube, but not a lot of people subscribe, which is strange. But they keep coming back.
And we want you to subscribe so you can be notified and eventually participate in the stream live. So
that'd be great. So yeah, this was interesting, and you guys can check the full video in a couple of minutes when it's available, and we'll be back in 2 weeks.
Yeah.
Thank you for watching. Bye.
Bye, guys.